In this lesson, we're going to be looking at the transformation of graphs. Now, this sometimes can come across as a bit confusing, I think, because people don't really get practice with it. But what I've tried to do is try to make this as interactive as possible, so I encourage you to go and try it out for yourself when you get a chance. Okay, so there's kind of like two scenarios that we'll look at as when that we're going to be changing something that's outside of the x bracket, or whether it's inside. So the first two scenarios are going to deal with things that are going to be outside this bracket. So if we take the function f of x, which is equal to x squared, what would happen if we added a number, just this number a? Well, what would happen is, if you think about it, because this x values are here, they're locked in, so the only thing that's going to change is the y. So if we slide this up, I'll turn this on, so if we slide this up and take it up to 10, what's happened is we've had this x squared, which is down here, it's our original graph in blue, and then we've added 10 to it, and then it's gone up by 10. So what would happen if we went negative? So if we go negative, this is exactly the same thing, but instead of going up, we go down. We go down by 10. You can make this any function you want. You could go x cubed minus 2x squared. So, but it will still be exactly the same thing. This, all it does is change its up and down position. It just changes that. Okay, so what about this scenario here, where we have f of x again equals to x squared, but now we've said that our new graph is what would happen if we put a minus sign on the outside of this f of x expression. Well, you can have a think about it. If it's minus, so what's going to happen is all the values are here. Just say this value here was positive 10. Well, now you're going to multiply this by a negative 1. So then it's going to become negative 10. So down here, it's just been reflected in the x-axis. It's been reflected because all the numbers have now gone from being a positive number to being a negative number. But again, this for all different types of graphs, minus 2x plus 3. You know, you can have as many complicated ones as you want, but what the real thing to note is that this red graph is the mirror reflection of this blue graph here. Okay, so now going on to the next case. So what about when you have y equal to, well, here we're saying if f of x is equal to sine x, okay, what happens when you multiply your f of x by some factor k? What's going to happen? Well, here we can see that what's going to happen is this is being multiplied. So this is 3. This, you know, which usually only goes up to 1, is being multiplied up to 3. And then if it goes to 5, it's a bit more clear here because it's 5. So this maximum used to be 1 because we know that sine graphs always travel between -1 and -1. But now we've multiplied it by this factor k. So the y value has gone from 1 to plus 5, and then here it's gone from -1 to -5. And this just affects the y values on this function. You can put any function you want in here. I'm going to link all these so you can go in it and see them for yourself. Okay, so that has been thinking about the changing of the y values. Okay, because what happens now if we start to look at the x values? Okay, so we've got our graph here of x squared again, and now we want to know what's going to happen if we do f of x plus a number a. But this time the number is inside of the bracket with the x. Okay, so it's going to affect its x position, not its y position. So let's see what happens. So if we go over here, or over here, let's just say we want to add 5 in there. So we add 5. So if a is 5, so add 5. But what's happened here is it's actually moved to the left 5. Okay, so the graph has been moved to the left 5. Okay, what happens if we put -5 in there? Well, it's moved to the right 5. It's moved over to the right 5. So actually by taking away, we've moved over to the right, and by plussing, we've added to the left. Now this can be a bit confusing. Some people you usually think if I add something, I'm going to be moving it that way, or if I minus something, I'm moving it that way. But in this scenario, it doesn't work like this. It's actually the opposite way around. So that's something you're going to have to try and remember. I can, if you're really interested in it, I'll attach a link for why the reason. But most people are just happy with just memorizing that. To plussing is to the left, and to the right is minusing. So this is inside the f of x bracket. But what about this scenario here? So if we have a function f of x is equal to x minus 5, so like we said before, this is f of x, and it's been shifted over to the right by 5. What would happen if we took the negative values of this function? What would happen if we minused all the values in here? Well, what happens is the graph is actually reflected. So what was 5 here is now going to be negative 5. Because of this, we've inversed the values that are in here. Like again, you could do this for any function. So let me try another one. Yeah. So one sec, I'll try and find it. So x. So yeah, as simple as y equals 2x plus 3. This is one we're all familiar with. So what would happen if we change the negative value? So actually what happens is it flips in this y, the y axis, or you could think of it as all the x values that were. So here, trying to find one that's on a nice line. Okay, so here we've got the point, 3.610, but when you take the negative value of that, it's going to be minus 3.610. So it's the x values that change here. Okay, and what about on our final case, when we have something like sine of x? Okay, and what we're interested in is looking at when we have this k factor inside of the brackets. And the last time we had like a k factor, we looked at it outside, and what happened was it multiplied the y value. But when we're looking at it inside, what's going to happen? Well, what's going to happen is it's actually going to compress this the number the x coordinate. I think it's frozen there. It's going to compress the x coordinates. So you can think about sine of x. So there's meant to be one rotation between 0 and 2 pi. But now if you make this factor 2, there's actually going to be, see this blue line, 2 waves between 0 and 2 pi. And then if you do increase it again, you'll have 3 waves, 4 waves, 5 waves, and it gets more and more and more and more compressed. Okay, so I know that's a lot to take in just one video. So I'd really, really encourage you to go have a look at these graphs, play around with them, put different functions in, and see how they change, because I think that's really the best way to learn. If you try to just memorize them, there's 6 different things that are all quite similar, so they're going to be quite, it might be a bit confusing to memorize. So I think the real key here is to go in, try them for yourself, and kind of get a bit of an intuition idea for what's happening with each one.